Welcome everyone. Today is May 12th, 2022, and today we are talking about unknown cone dimensions. Unknown cone dimensions. So previously, we've been solving for the volume of cones, but what if you're told the volume and you have to find some other dimension? We're going to start with an example cone right now. Let's zoom in so we can draw it and just get a rough sketch. All right, this cone appears to have a pretty wide base, and it's not very tall. Here's our cone. The radius is here. The height is going to be given to us. It's 3, let's call them inches. Okay. So let's remember the formula for the volume of a cone. The volume of a cone is 1/3 times pi times the radius squared times the height. Now, the volume of this cone is given to us. In the problem, it says that the volume is 64 pi cubic inches. Also in the problem, we're told that 64 pi equals 1/3 times pi times the radius squared times 3. So really all the problem is telling us here is that the volume is 64, and I just replaced that letter V in the equation in the original formula with 64 pi. And we know that the height is 3, which was right here, and that's why it's right here. So all we've done so far is we've replaced letters in our formula with numbers from this specific cone. Here's our specific cone, whose volume is 64 pi. So now the question is, let's write down the question. What is the length of the radius of this cone? All right, to find that out, we're going to solve this equation like we would any other. Now, I'm noticing there's a pi on both sides of this equation, and I see that the only operation that's really going on here is multiplication, so I'm going to divide it all by pi. So let's come down here, we'll rewrite the equation, and we'll divide the whole thing by pi. So 64 pi is 1/3 times pi times radius squared times 3. And now we're going to take the whole thing, just like this, and divide by pi. And I know that pi divided by pi is 1. And over here, same thing, pi divided by pi, that's just 1. I'm writing a big 1 through them. So now we get 64 over here on the left equals, and then on the right, all we have is 1/3 times r squared times 3. Now, we know that multiplication can get rearranged. We know that I can rearrange 1/3 times r squared times 3 to make it 1/3 times 3 times r squared, just to make those a little closer together. So I know that 1/3 times 3 is 1. Those are reciprocals of one another. So 1/3 times 3 is 1. So we get 64 equals 1 times the radius squared. And really that just means that 64 is r squared. So 64 is the square of the radius of our cone, I know that the inverse of squaring something is to find its square root. So I'm going to find the square root of both sides of my equation. And I find that the radius of this cone is 8 inches, which explains why it looks so squat. It looks so low to the ground. The radius is much longer than the height. And that's it. That's how we find that. So again, if your unknown is not the volume, you just need to replace all of the letters in the formula that you have numbers for with numbers, and then solve for the remaining letter, the remaining variable. So here we've got r. R was the unknown here, and so we just isolated r and found the length of the radius.